Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so question 7 says in the circuit diagram below, the battery has an EMF of 6 volts and negligible internal resistance. Then for 7.1, they say calculate the effective resistance in the circuit. Right. Now with this kind of circuit here, when you have this here, you can tell that if our current is flowing in that direction, then what we see here is that the current at this point will split and then go to this direction here, and then some of the other current will split and go to that direction. So looking at this, we can see that since we have multiple pathways for the current to flow, this must be connected in parallel, right? But then looking at the 4 ohm and the 2 ohm resistor, we can see that they are connected in series, but a combination of the 4 ohm and 2 ohm resistors are connected in parallel to the 3 ohm. Now, the way you deal with such a question is that you will have to combine these 2 resistors that are in series to form one big resistor, which will be parallel to the 3 ohm resistor. So in this case, you cannot say all these 3 resistors are in parallel, therefore you will say 1/4, 1/2, and 1/3. It's impossible to do that because the 4 ohm and the 2 ohm are actually in series. But then now we want to say, since the 4 ohm and the 2 ohm are both parallel to the 3 ohm resistor, then let's just combine them, and then they form this one big resistor that is in parallel to the 3 ohm resistor. So how do we then calculate our effective resistance in this circuit? We will say 7.1.1, that's 1/Rp is equals to 1/R1 plus 1/R2. So we have our resistor here, which is 6 ohm, and then we have the other resistor there, which is 1/3. Now, obviously, at this point, we know that in order to calculate the resistance of the parallel, we need to inverse this by just saying this is 1/Rp. If we can just do this to the exponent of -1, and whatever that we do on the left-hand side, we also do on the right-hand side, then that means we'll be left with Rp being equals to 2 ohm, right? And then just like that, you have your 3 marks. So that's how we are supposed to calculate the effective resistance of the circuit. And since we have included all the resistors in here, that means we are done, right? And then for 7.1.2, again, we are given 3 marks. Now we know with the 3 mark question, it's just a matter of writing the correct formula, substituting into that particular formula, and get yourself the correct answer together with the correct SI unit. So if we are looking for the current, the reading on ammeter A1, so we know this is the current because what does the ammeter do? It reads the current, right? So pay attention to how they ask you these questions. So they do not say calculate the current in A1. They just say calculate the reading on ammeter A1. Then we know by so doing, we are calculating the current. The current of what? The total current. Right, so the current that flows in the whole circuit. Now, if we want to calculate the total current, we do know that we can make use of the total resistance and also the total voltage there, right? So we do have our formula here. The original one, R is equals to V/I. But if we want to calculate the current, we can then manipulate the formula and write it as I is equals to V/R. And then at this point, we substitute our total voltage, which is 6, and then substitute our total resistance, which is 2. Now, if we say 6 divided by 2, we get 3 amperes, right? So that becomes our total current, right? And then now for 7.1.3, they say calculate the reading on A2. Right. So how do we then calculate the current on A2? Remember, we just calculated this one here to be 3 amperes. And then what we can do here is that since we know that the way we are seeing this, this whole circuit is that we have the 6 ohm here, and then we have the 3 ohm here, right? Since the A2 was in between 4 ohm and 2 ohm, that means it is reading either the current of the 4 ohm or the current of the 2 ohm. It doesn't matter because we know that since these ones are connected in series, they share the same current. So the current in the 4 ohm resistor is definitely equal to the current in the 2 ohm resistor. So even if you were to combine these two resistors, the current would still remain the same. But then now I want you to look at something here. We have this A1 here, which is measuring 3 amperes. And then these resistors here, we are told that they are connected in parallel. But what do we know about resistors in parallel? Now, for parallel resistors, we know that this resistors, they divide the current, right? So this current these resistors divide the current amongst the resistors. So we call the parallel resistors current dividers, right? So essentially we know that these two resistors here will have to share this 3 ampere, right? Now, if we are looking for the reading on A2, we can just say, okay, let's figure out the ratio of the 6 ohm to the 3 ohm resistor. Right, now if we simplify by the smallest number here, which is can be divisible in both these numbers, we end up with the ratio of 2:1. Right, but then if we want to calculate the current of the 6 ohm resistor, which is the current here for A2, then this is what you do. Now I need you to pay attention to this. It's a very easy process. Now, we do know that the relationship between resistance and current is inversely proportional. So the meaning of this is that the bigger the resistance, then the lower the current, or the lower the resistance, then the bigger the current, right? So we're gonna kind of use that inverse relationship here to calculate the current that will flow in this 6 ohm resistor. By doing what? If we want the current in the 6 ohm resistor, that means since this relationship is inverse, we would have to take the ratio of the 3 ohm resistor. Note, I want the current of the 6 ohm resistor. I take the ratio of the 3 ohm resistor, and then I divide it by the total of the ratios. Now, what is the total of the ratios? You get it by saying 2 plus 1. So you get it by adding the two ratios. So if you say 2 plus 1, you end up with 3, right? And then you have to take this fraction here and multiply it by the total current, since the current that they're sharing is this 3 amperes, right? So now you are saying that the ratio in which they share this 3 amperes is a ratio of 2:1, right? So in order to figure out the current that would have to flow in this 6 ohm resistor, then this is how you do it. You say 1/3 and then multiply that by 3. Now, if you just do that, you will end up with 1 ampere, because 1/3 multiplied by 3, that's equals to 1. So that's 1 ampere. Now, in other words, the reading on ammeter A2 is equals to, so therefore the reading on ammeter A2 is equals to 1 ampere, right? So again, if you wanted to find the current that flows in the 3 ohm resistor just for interest's sake, then what would you do? To find the current that flows in the 3 ohm, because of the inverse relationship, what do? You take the ratio of the 6 ohm resistor. So you take, to find the current of the 3 ohm, you take the resistance of the ratio of the 6 ohm resistor, and then divide it by the total of the ratios, and then multiply that by 3. And then if you do that, 2 times 3, that's 6. 6 divided by 2, that's 2 amperes. Then you would see that they would share this current. So the current in here would be 1 ampere. And then since it's the same current that will pass in here, that's 1 ampere. So meaning your A2 is just reading 1 amperes. But then here we read 2 amperes. Now, if you can say 2 amperes plus this 1 ampere, then you get the 3 amperes there. And then that's just how you look at these questions. Now, one thing that you always have to remember, when it comes to resistors that are in series, you do not add these two currents to find the total current, because we are simply saying the current that passes over the 4 ohm resistor is the same current that will pass over the 2 ohm resistor, right? So therefore, that's the same current that we are talking about. So we are adding the 1 ampere that flows in here and the 2 amperes that flows in here to get the 3 amperes over there, right? So that's just how we tackle that question there. So yep. And then now, to calculate the power dissipated by the 4 ohm resistor, how do we do that? 7.1.4. We are given 3 marks again. So now we want the power dissipated by the 4 ohm resist. Now, the first thing that you want to do, you want to look at your formulas for power. So you have plenty of them. You have P is equals to V over I. And then you have P is equals to I squared times R. And then you also have P is equals to V squared over R. Now, you can use one of these formulas to calculate your power by just saying, we have already concluded that the reading on A2 is 1 ampere, which means that since these resistors are connected in series, they also have the same current of 1 ampere, and then here also 1 ampere. But then remember, we are only focused on the power dissipated by the 4 ohm resist. Now, obviously, your choice of formula will be based on what you have, right? So you do not just take any formula. The formula needs to be based on the data that you have. Now we can say that here we have the current and then we also have the resistance. Now the one formula that is suitable for us to use to calculate power is obviously this one here. Since we're going to substitute our current and our resistance. Now that means we're going to say P and then I squared multiplied by R. And then what is our current? That's 1. And then what is our resistance? That's 4. Now, if we say 1 multiplied by 4, we get 4 watts, right? Remember, you must also include the correct SI unit. Now, 7.2, it's saying, what is the reading on voltmeter V? And then no calculation is required. So what is the reading in here? If we consider that the fact that these resistors are connected in parallel, we know that if resistors are connected in parallel, we say the voltage or the potential difference is the same throughout. So voltage is the same throughout resistors that are connected in parallel, right? So we know that if we have 6 volts here, and then we do not see any resistors that are connected in series anywhere here before this branch here, before the parallel branch, then we know that we have to have 6 volts in here, right? So if we have to go back and consider that if we combine the two, we have 6 ohm, and then here we have 3 ohm, that means the voltage in here is 6 volts, and also the voltage over here is 6 volts. Remember again, if we are considering parallel resistors, we do not add the 2 voltage, right? We do not add the 2 potential differences because we are simply saying the voltage that flows in here is the same voltage that flows over there, right? So for 7.2, we were only required to say 6 volts, right? So no calculations required. Then 7.3 says a kettle is rated 1,500 watts, right? And then let's clear that. So a kettle is rated 1,500 watts. Calculate how much a learner will pay for electricity for using the kettle for 4 hours. Eskom charges 1 kilowatt hour electricity at 2.05 cents, right? Then how do we calculate that? So to calculate that, we have to consider the formula that we use to calculate cost. So we say cost is equals to kilowatts hour multiplied by the tariff, right? So the tariff is the charge, right? The Eskom charge. Then now we can say that this one is in kilowatts. So that means we have to convert this 1,500 watts into kilowatts. How do we do that? Converting watts to kilowatts we know that we have to multiply it by 1,000. So the first thing that we want to do here is say 1,500, then multiplied by 1,000, so that we have our answer in kilowatts. Then multiply that by the number of hours. So they said they use the calculator for 4 hours. So that's 4. And then multiply that by the tariff, which is the cost of 2 rand, 0.05. Now, obviously, here we're going to end up with 1.5. So that's 1.5 multiplied by 4 multiplied by 2 rand 0.05. And then you just have to punch all that into your calculator. Then you end up with 12 rand 0.30, right? So 12 rand 30 cents, right? So that would be the cost of using your kettle for 4 hours, right? And then that's how you go about answering this question for a total of 17 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.